All right, I'm back. We are on page 2 of the Calc AB Notes 6. If you're watching these consecutively, you just saw me cut myself off because I accidentally ended the video for page 1 instead of switching back to the notes. But anyway, we went through the process, right? We're finding derivative with respect to whatever the independent variable is. And we're doing it in situations where it's challenging or just impossible to actually solve for the dependent variable. So these are implicit relationships, and they're really interesting. So let's see another thing that we can do with this. So we want to, in this particular case, we want to find the second derivative with respect to x. So remember, this is telling us x is the independent variable. And we want to find the answer in terms of x and y. And we'll see why that matters when we do it. So let's start off. We have to first find a first derivative. So I'm going to do this problem right here. So it's the derivative with respect to x of x squared plus y squared is equal to the derivative with respect to x of 16. All right. And on the right-hand side, I'm going to remember that derivative is 0 because that is the biggest mistake I see. On the left-hand side, all right, the derivative with respect to x of x squared is 2x. Now, when y is involved, always think about the chain rule. The derivative of something squared is 2 times that thing times the derivative of that thing. The derivative of y with respect to x is dy dx. And in this problem, if you forgot that, you wouldn't even have a dy dx in your problem. You'd be like, what is going on? But we remembered it. So here, I'm going to solve for dy dx. So I get sometimes, so I have this new stylus, and if I double tap, it switches between the eraser and the marker or pen or whatever. And it turns out that I have like a nervous tick where I tap it a lot, and that's super annoying. And I wish I would stop. All right, so dy dx is subtract 2x, divide by 2y, so negative x over y. All right, but what's the problem? The problem is to find the second derivative. So what we're going to do is the process again, right? So we're going to go d dx of dy dx, which is just the second derivative, is going to be d dx of negative x over y. Okay, so where do we go with this? It's a quotient, so I'm going to use a quotient rule. On the left-hand side, I just have to know the notation. So the second derivative with respect to x. All right, so I'm going to put the negative with the numerator, I think. So I'm going to say it's bottom derivative of the top is, oh gosh, -1 minus the top, which is negative x. Derivative of the bottom, the derivative of dy dx. Sorry, the derivative of y is dy dx. And then all over the bottom squared, so y squared. Okay, so now where do I go from here? First, I'm going to move this over a little bit because I started way too far over. I'm going to simplify this on this line below here. It becomes a space issue, like every problem. Trying to write with a lasso tool. Okay, second derivative. Okay, I have negative x plus, no, what? No, I have negative y. So negative y plus x. Now, what is dy dx? Well, look back up right over here. We said dy dx is negative x over y. So I'm going to make this replacement negative x over y, then over y squared. So this is common denominator, negative y squared minus x squared over y, and then all over y squared. And then I'm going up and over here. And I will say that I'm going to simplify that, right? So scroll so you can see it. So the second derivative with respect to x is negative quantity y squared plus x squared over y cubed. Okay, so that's a little interesting. Now, this is not the answer that you would usually see. And the reason for that, and this is extremely clever, and the first time you see it, usually you didn't see it. You didn't see it coming. This thing is actually the original given. What the heck? Which means that I can say that the second derivative here is just negative 16 over y cubed. Isn't that amazing? We can make that substitution at the end. It's like the first time I ever saw that, I was just like, what's happening? And it's this really cool thing where the original problem like cycles back into it somehow. That happens a lot with conic sections, like a ton. Let's try the next one and see. So that was a circle, right? This one's an ellipse. Let's see if the same thing happens. I don't know if you remember your conics. If you don't, turns out in Calc AB, they're like not that big a deal. So you're probably okay, but I mean, maybe go back and review. All right, derivative with respect to x. It's going to be the derivative with respect to x. So that's good. All right, derivative of x squared, oh my God, is 2x. The derivative of 4y squared, okay, the derivative of 4 times something squared is going to be 8 times that thing, times the derivative of that thing, which is dy dx. So we get dy dx is negative x over 4y when you kind of like simplify it. We want to keep going, right? Because we want the second derivative. So the derivative of both things with respect to x here. So d dx of dy dx. Now I'm going to take out negative 1/4 to avoid making 1,000 errors that I know that I'll make. And so you should use that constant multiple rule whenever you think it's going to make your life better. And here I think is an example where it's going to make my life better, potentially, I hope. So here, this is the second derivative of y with respect to x. So d squared y dx squared. It looks really weird. Negative 1/4. There we go. Bottom, derivative of the top, minus top. The derivative of the bottom is dy dx. So dy dx over the bottom squared. Okay, so now we want to do the same sort of thing. So we look for our dy dx up here, and then dy dx here. We're going to make a substitution. And where am I going to fit all this? I'm going up here, I guess. So that's the second derivative. It's going to be, how much simplifying can I do here? So, like, not a lot yet. So negative, mostly I want to simplify so I can fit things. So I'm going to do y, because it's y, and then plus x squared over 4y, and then over y squared. Gross. This is, oh, and also my face is right in the way. So there we go. And then common denominator type of deal. So let's see, second derivative respect to x is going to be negative 1/4. So I'm just going to go for it here. We'll get 4y squared plus x squared. 4y squared plus x squared. Sorry, over. So then the common denominator in the numerator is 4y, and there's a y squared in the current denominator, so I make it 4y cubed. And so our second derivative is, well, look for the thing, right? So right here, I see this. Whoa, okay, I got Siri up here. Stop, go away. Ah, all right. I don't know what made that happen. I said this, and somehow that triggered it. So I'm gonna get negative, that's just 1. So I get negative 1 over 16y cubed, it looks like. All right, so could we check this? We could check this. I'm gonna come back in the next video and check it, and if it's wrong, I guess I'm gonna change everything. So I guess you're in this for at least 2 videos. So I'll see you in the next video when I'm gonna check this on the calculator and then do the rest of the page. So see you then.